This conference will now be recorded.
So today let us start off with one more new topic and very important one, collections. So any project we take related to Java, we make use of collections in that. That much important it is. So before we go to these collections, we can even collect the elements by using arrays. When we go with arrays, when you are allocating memory for array, do we need to give size here compulsory? Do we need to provide the size compulsory for arrays? Yes, right? We have to give the size compulsory. So if I go with the size like 50, we can collect maximum 50 elements only. To go with the size like 50, we can collect what? Maximum 50 elements. We cannot decrease the size or we cannot increase the size. So arrays are what? Fixed size. So that is the main drawback of arrays. That is a place where we go with collections. So you can say collections are used to collect the elements of variable size. Means not fixed, unlimited collection of elements. Let us understand very important intro question, arrays wise collections. Let us understand what is the difference between arrays and collections. The main difference is in arrays we can collect the elements of fixed size, whereas in collections we can collect the elements of variable size, means not fixed. How many elements we want to collect, we can collect. One more important difference is in arrays we can collect only similar type of elements, whereas in collections we can collect different type of elements. One more very important difference, in arrays we can collect primitive type as well as reference type of elements. In arrays we can collect what? Primitive type as well as reference type of elements, whereas in collections we can collect only reference type of elements. This is very important difference. I'll discuss more on this point again with an example. Now let us move to the major topic of these collections, that is collections hierarchy. This diagram is very important. Collections hierarchy. The topmost two interfaces under collection hierarchy are collection, and one more is map. The topmost two interfaces under collection hierarchy are collection and map. In the diagram, this symbol indicates they are interfaces. These two are what here? Interfaces here. Now, when to think of collection and when to think of map is, collection is used just to collect only the elements, whereas map is used to collect the elements in the form of key value pairs. You can collect the elements in the form of key value pairs. Like you can say employee number, the value of employee number, employee name, the value of employee name, salary, the value of salary, We can collect the elements in the form of key value pairs. That is the use of map. Under collection, it goes with the two sub-interfaces. Under collection, it goes with the two sub-interfaces. One is list and one more is set. List and set. When to think of list and when to think of set. List is ordered. List is what? Ordered. Whereas set is unordered. Set is what? Unordered. Okay. List allows duplicates. Duplicates means same element can be repeated. Whereas set does not allow duplicates. Does not allow duplicates. No duplicates in set. Like example, if you take the elements like 5, 8, 6, 4, 7, the meaning of ordered in collection is the way we accept, the way we get. So the result also will be 5, 8, 6, 4, 7. The way we are accepting, the way we get. That's the meaning of ordered in collection. Unordered. The meaning of unordered is we don't know in which order it's going to pull out the elements. Then we are in one more term, sorted. Sorted means arranges the elements in either ascending order or descending order. Arranging elements in either ascending order or descending order is sorted. Right? So whatever the words I'm saying, I'm going to document all these words at the end again. Now, goes with the subclasses like ArrayList, ArrayList, and LinkedList. Very, very important one, ArrayList and LinkedList. Now, when you go with ArrayList, it's going to collect the elements stored in continuous memory locations. When you go with ArrayList, the elements are stored what? In continuous memory location, similar to arrays. But the major difference is arrays are fixed size, ArrayList are variable size. So when you go with ArrayList, it's going to collect the elements stored in continuous memory locations. Now, here also it goes with index based. So the index starts with what? 0. 0, 1, 2 like this. Now, let us suppose in our list we are having some elements. In our list we are having some elements like 10, 20, 30, 40 and 50. Now, in this list we want to add an element 25. In this list we want to add an element 25 in between 20 and 30, means in index 2. In index 2 we want to add an element. Then the algorithm, the logic is we should go to the last element and shift that last element to the next location. Like that we have to shift one element to the next location until you get space where you want to insert. So in the case of ArrayList, whenever we want to insert or delete the elements, we have to shift the elements. We have to move the elements to the next locations or previous locations. Like example, if you are having 1000 elements in your list and we want to insert an element at first, then we need to do 1000 shift operations to the next locations. If I want to delete the first element, then again we have to shift the elements near to 1000 times to the previous locations. Shift operations are time consuming. It takes more time in order to shift the elements. Depends on the number of elements or where you want to insert. Means the cost of insert and delete operations are more. In the case of ArrayList, whenever you want to insert or delete the elements, the time what it takes is more. If your application is having lot of insert and delete operations, if your application is having lot of insert and delete operations, then we go with what? Linked list. We go with linked list. In the case of linked list, the elements are stored in non-continuous memory locations. In the case of linked list, the elements are stored what? In non-continuous memory locations in the form of nodes. In the form of nodes. A node is divided into two parts. A node is divided into two parts. The first part contains the element value. The first part contains the element value in 2030. And let us suppose the address of first node is some 100. The address of second node is some 200. The address of third node is some 300. In the node, the next part contains address of the next node. It contains address of the next element. It holds what? Address of the next element. For last one, it goes with null, means no element connected. Since the elements are connected with each other, that's the reason the name has come linked list. So I'm repeating. So what is linked list? It's a collection of elements in the form of nodes. A node is divided into two parts. The first part contains the element value and the next part contains the address of the next node. Now, in this linked list, we want to insert an element in between 20 and 30. Then the algorithm is what? The logic is just we have to create a new node. Just we have to create what? A new node with an element value 25. And let us suppose the address of this new node is some 250. Then what we have to do? We have to replace this 300. We have to replace this 300 with 250. We have to replace 300 with 250. And for the new node, the link part, the next part we have to make it as 300. So the link will come now from 20 to 25 and 25 to 30. And the link between 20 and 30 will break here. So in the case of linked list, whenever you want to insert an element or delete the element, we just change the addresses. What we do? We just change the addresses. We won't do any shift operations. We won't move the elements here. Only change of addresses. That's the reason when your application is having lot of insert and delete operations, it is preferred to choose linked list over ArrayList. Right? So don't worry how to write the programs, how to shift the elements, how to change the addresses. So that is not the role of programmer here. I've just explained the internal working of ArrayList and linked list when you are doing insert and delete operations. So in our program, simply we use a method. Simply we use a method add. We use a method add and index and the element where you want to insert. So when we use this add method with ArrayList object, so in index 2, 25 element will get inserted. And what is the internal algorithm of add method of ArrayList? It's going to shift the elements. Whereas same method here also add 2, 25. Here in this case of linked list, it's going to change the addresses. So writing code of collection is very, very simple. Just we have to play with the methods. Choosing the right class and using the methods, that's the main part of collections here. That's the main role of programmer. So internal logics are taken care by your language only. Clear up to here, all of you? Any questions? No. Coming to set. Set is what? Unordered and no duplicate elements. Under this, it goes with the subclasses like as set, sorted set, and under asset we are having linked asset, under sorted set, tree set. Asset is unordered. Asset is what? Unordered and no duplicate elements. Let us suppose if the requirement is to go with orderedness. So to go with orderedness, we can think of list. But we don't want to allow duplicate elements. We cannot go for list now because list allow duplicates. Then the solution for this one is linked asset. So linked asset is ordered and no duplicates. Coming to tree set is sorted. Means it's going to arrange the elements in ascending order or descending order. Coming to map, map is similar to set only. The main difference is key value pair. In the case of map, the elements will be in the form of key value pairs, and the subclasses are like hash map, sorted map, linked hash map, and tree map. Concept is same. Hash map is unordered based on keys. Linked hash map is ordered based on keys, and tree map is sorted based on keys. It's based on keys here. Now, let me document all these parts. So the document, whatever I'm typing, it's very important during interview times. So first one, collection wise map. Collection is used to collect only the elements, whereas map is used to collect the elements in the form of key value pairs. The elements will be in which format? Key value pairs. Like example, if you say, if you go with collection, the elements are enclosed in between square brackets. In the case of collection, the elements are enclosed in between square brackets and the elements are separated by comma. Elements are separated by comma. In the case of map, the elements are enclosed in between curly braces. When you see curly braces, they are map. Here we go with the key. Here we go with the key and the value of the key. Again, comma, key, and the value. Key and the value. Comma, key, and the value. So the data will be enclosed in between curly braces and it will be in which format? Key equal to value, key equal to value. And every key value pair are separated by what here? Comma here. Every key value pair is separated by comma. Clear the difference between collection and map, all of you? Now, list wise set. List is ordered, whereas set is unordered. List is ordered, whereas set is unordered. List allow duplicate elements, whereas set does not allow duplicate elements. So more about duplicate elements we'll discuss when we come to set concept, set interface. Like example, if you go with the elements, like 5, 8, 6, 4, 7, the meaning of ordered is the way we accept, the way we get. It's meaning of ordered. Unordered means we don't know in which order it's going to pull out the elements. We are having one more, sorted. Sorted means arranges the elements in either ascending order or descending order. Right. The next important one, ArrayList wise linked list. In ArrayList, The elements are stored in continuous memory locations. In ArrayList, the elements are stored what? In continuous memory locations, whereas in LinkedList, the elements are stored in non-continuous memory locations. Non-continuous memory locations in the form of nodes. A node is divided into two parts. Element value and link to the next node. The next important difference, the cost of insert and delete operations. The cost of insert and delete operations. Cost means the time what it takes to do insert and delete operations are more in ArrayList, whereas the cost of these operations are less in LinkedList. So when your application is having lot of insert and delete, then think of the class LinkedList. One more important difference, ArrayList occupies less memory than LinkedList. So if your application is not having more insert and delete, then think of ArrayList only, because it occupies less memory than LinkedList. Okay. Next one, asset. Asset is unordered and no duplicate elements. Linked asset is ordered and no duplicate elements. Reset is sorted and no duplicate elements. Similar way, hash map is unordered, based on keys and no duplicate keys. Linked hash map is ordered, based on keys and no duplicate keys. And finally, tree map is sorted, based on keys and no duplicate keys. Right. Today we'll be discussing about list interface. In the next class, we go with set and map interface. Any questions, anyone up to here? No. Let us move to the methods of list interface. So some of the methods it has taken from collection interface. The methods are like Boolean add, which takes object as an argument. So why object? Because in collections we can add only reference type. And what is the topmost reference type? Object. The use of this method is adds an element at last. It's going to add the element at last. And if it is able to add the element, returns true, unable to add, returns false. Void add int comma object. This method adds an element at a given index. So this first argument is index and this is the element which you want to add. So the one what I have shown in the diagram, this method. You have to provide the index and the element which you want to add. Next one, void set set int comma object updates or modifies the element at a given index. At the particular index, you want to change the element. You want to update the element, then we go with set method. Then Boolean remove object deletes the given element. Whatever the element you are passing to this remove method, that element will be deleted. And if the element is deleted, returns true. Unable to delete, returns false. Why it is unable to delete? If the element is not present in the list. Object remove. We are in one more overloaded remove method with index based. This one deletes the element at a given index. And that element will be returned here. Object get method with index based returns the element at a given index. The last one size returns the number of elements. How many elements present in the list we can know by using size method. Let us understand all these methods by using the program, and let me show the program using ArrayList class. I'm going with the program ArrayList demo. One more point. All these classes and interfaces are present in a package java.util package. So whenever you want to use these classes or interfaces, we need to import what? Java.util package. Now, let us understand these all methods using a program now. Open Eclipse. To store collection related programs, let us create a new class or new package. Let us create a new package, collections. And under collections classes, let us create a new class, ArrayList demo. With main method inside. Now, what we have to import? Import java.util package. Now, whichever the collection class we want to use based on the requirement, we have to just create object of the class like this. ArrayList al equal to new ArrayList. And once you create object, just we have to call the methods. Here I want to call al.add 10. We are adding an element 10. How to add the elements into the list? Using add method. And the element you have to pass. al.add 20, al.add xxx. We can add different type of elements. al.add yyyy. Like this. We can add different type of elements. Now if you print the object, al, then see the output what we get. See, the elements are separated by comma enclosed in square brackets. And the way we add, the way we are getting, that is the meaning of ordered. So this is the meaning of what? Ordered here. Now, if you add an element, al.add 10, it's a duplicate element. So this is what? Duplicate element. Now, when we run, even that 10 will get added. That's the meaning of duplicates are allowed here. That's meaning of duplicates are allowed. Now, if you write al.add 2 comma ppp. So in second index, we want to insert an element ppp. Second index means 0, 1, 2. So here in this before xxx, we will be inserting ppp. Now the result will be, to print al, the result will be 1020 ppp xxx yyyy and 10. These elements will be shifted to the next location. Then it's going to have the space to insert. Now if you call the method al.set 2 comma qqq, the second index element will be replaced with qqq. Now if you print the object al, the result will be 10, 20. The second index element will be replaced with qqq. So this ppp will be replaced with qqq. Then xxx, yyyy, and 10. If you call the method al.remove qqq, so qqq will be deleted. Now if you print the object al, the result will be 10, 20, xxx, yyyy, and 10. If you call the method al.remove second index, I want to delete the element at second index, means which element? 0, 1, 2. So xxx will be deleted. Now if you print the object al, now the result will be 10, 20, yyyy, and 10 here. Right? Xxx will be deleted based on index here. Now, if you take string s equal to al dot get of 2. So what is the element at second index? 0, 1, 2. What is the element at second index? Yyyy. So that yyyy will come and store into s variable. Then just print the value of s, which will be yyyy. Here we are getting an error under get method. So the reason is, see the reason? The get method return type is what? See, get method returns object. But you are assigning to what here? String. See the error what it's saying? The type mismatch cannot convert from object to string. Okay. So here we have to apply the typecasting. So we have learnt typecasting in basics for primitive type only. We have seen for primitive type. So when you go with primitive type, when you want to convert one type into another type, we have to see the sizes, 4 bytes, 2 bytes like that. Whereas coming to reference type, we have to see the hierarchy. We have to see what here? Hierarchy. So what is the return type of get method? Object. What is the return type of get method? Object. You are assigning to what here? String. You are assigning to string. So string is what? It's a subclass of object. String is a subclass of object. So hierarchy wise, this is higher and this is lower. So in the case of reference type, when you are going with typecasting, we have to see the hierarchies. We have to see what hierarchy. In this case, object is higher than string. So when you are converting higher to lower, we have to apply the typecasting. So here, just to keep mouse pointer on error, and you can see the option add cast to string. Just to click here, it's going to apply the casting here. Clear all of you? Typecasting for reference type. Now, size equal to al dot size. So in our example, what is size now? Carrying totally 4 elements in the list. Now see when we run, same output what I have given in comments. Right? Any questions, anyone? No. At the beginning, I said in collections we can add only reference type of elements. But when you are adding 10, 10 is what your primitive type. So even though I pass primitive, it is accepting. So why it is accepting is because of a feature called as autoboxing. Because of what feature? Autoboxing. Added in Java 5 version. Added in which version? Java 5 version. So what is this autoboxing is? Autoboxing is converting respective primitive type into reference type or vice versa. Vice versa means reference to primitive, vice versa automatically. This feature is known as autoboxing. So even though you pass primitive, but if the argument is of type reference, the conversion will happen automatically, and that feature we call autoboxing. Prior to Java 5, we used to write the code like this: al.add new integer of 20. This is the way we used to write the code prior to Java 5 version. Prior to Java 5 version, we used to convert into reference and pass it. But this is not required from Java 5. Just pass primitive. Internally, it's going to convert into reference type. That conversions, automatic conversions only we call feature autoboxing. Clear all of you what is autoboxing? Right? Now, instead of array list, if I go with a linked list, instead of array list, if you go with the class linked list, then what do you think the output will be? Same output, no change in the output. It is same as it is. Then what is the difference? Performance. So the add method of linked list, the remove method of linked list, performance wise, these are more faster. Because if I use add method with array list, it's going to shift the elements, move the elements. Whereas in linked list, it's going to change the addresses. So performance wise, linked list methods are faster than array list methods. That's only the difference here. In linked list, we can use all these methods. We can use all these methods. In linked list, there are some more additional methods. Additional methods in linked list class. Self-explanatory. Add first, add the element at first. Add last, add the element at last. Remove first, remove the first element. Remove the last element. These are some more additional methods present in linked list class. Now, based on this, let me go with an assignment. Write a program to do the following linked list operations. Write a program to do the following linked list operations. They are: 1. Add element at last. Add element at first. Third option, add element at given index. Update the given element, update the element at given index. Delete the first element. Delete the last element. Delete the given element. Delete the element at given index. Display the elements. Exit. What you have to do? Just to create linked list class object. Just to create linked list class object and provide the menu to the user. Based on the option the user selects, by using linked list class object, we have to call the respective methods. Call the respective methods based on the option what you are choosing. The menu should display. The menu should display the elements. The menu should display repeatedly until the user chooses exit. When the user chooses the option exit, then only we should come out. Means we have to keep the menu inside the loop. The element value and link index need to be accepted during runtime using scanner class, complete dynamic application. So we have to accept this element value or indexes during runtime using which class? Scanner class. Then based on the option what user chooses, by using linked list class object, we have to call the respective methods. Clear with this task, all of you? Right? That's about for today. And in the next class, we'll go with the remaining topics of collection like set interface and map interface. Thank you all and happy weekend.
Thank you, Raj.